So welcome everybody to this September webinar hosted by ODLAA in conjunction with FLANZ. ODLAA is the Open and Distance Learning Association of Australia, and FLANZ is the Flexible Learning Association of New Zealand. In case you weren't aware, ODLAA is an international professional association of educators from all levels of, and areas and forms of education, people who are dedicated to the advancement of research, practice and support of education that happens across time and space. One of the great attractions of ODLAA is its journal, and that journal is called Distance Education. Actually, as a member of ODLAA, you receive a hard copy of the journal every issue that's published during the length of your membership. So it's a really, it's a good attraction to join up to the association if they haven't already done so. Many of the topics of our webinar series this year have been presented by authors who have published in recent issues of the journal. And once again, that's the case for today's webinar. I'd like to introduce you to one of the authors of a very interesting article. And I've just noticed that the co-author, one of the co-authors has joined us as well. Wangdi Jing from the University of Florida, and also Chenglu Li. So welcome. The article is called Toward Building a Fair Peer Recommender to Support Help Seeking in Online Learning. Provision of support and help to online distance learners can be a real challenge, and narrowing that sense of separation felt by both teachers and learners in time and space is exacerbated in settings where there are many students. And the potential for artificial intelligence to provide educationally sound support for learning is something that researchers have been exploring for a long time. The study that we're going to hear about today tackled this issue, examining the nature of AI systems built into online discussion boards to provide fair and accurate help seeking and support for the development of student self-regulated learning capabilities. I found the article very deep and intense, and I probably didn't summarize anything along the lines accurately there. So I better hand over to the reins to Wangdi and Chenglu to tell us more about this very interesting study. Please feel free to add your comments and thoughts in the chat as we go along, and we'll make sure that they're attended to along the way or at the end. So over to you.
Okay, thank you, Sarah, for the introduction. So I will share my screen. I prepare some slides, so I'll go over this article. Welcome, everyone. So give me 1 sec. Let me bring up my slides. Where? I cannot do this.
That's okay.
I was not able to share. Can you maybe enable the share? I cannot click the share.
Can't you?
Yeah. Little weird.
Sarah, have you put at the bottom there that multiple people can share?
It's set up for that, yes.
I can share.
Okay.
I've got access.
How about that?
Can you guys try and can you share?
I just re-clicked the multiple participants can share simultaneously.
Okay. Yeah, I got it.
Yeah. Okay.
It works now.
Okay. Good.
Oh, okay. Can you see my screen?
Yeah, it's coming through.
Yeah, that's good. Thank you.
Are you seeing my this screen or my? Does this screen work?
We see your notes as well as the slides. So yes.
That's weird. Why can't I share my second screen?
Oh, it's annoying, isn't it?
Yeah. How about now?
Yes.
Yeah, that's good.
That's good.
Okay.
Great.
Okay. Thank you, everyone, and I'm very honored to join this talk and introduce my paper, also with my course and my PhD student Chengdu Li here. So this paper is called Towards Building a Fair Peer Recommender to Support Help Seeking in Online Learning. And specifically, I will first talk about why we need to cater to fairness in AI education in general before I talk specifics about this paper. And then I will talk about our efforts on using, how the background information to build a fair peer recommender to connect online help providers and the seekers. Meanwhile, I will also, if the time allows, I will also discuss some other works fall within the spectrum of, fair AI and artificial intelligence in education in general. This talk will cover, roughly 3 areas. As I said, I will, before I talk about fair AI in education, I will first give some brief background information on AIED and my research interests in AIED. And for artificial intelligence in education is generally considered is an interdisciplinary area over computer science, psychology, and education. Computer science provide the algorithms and machine learning data mining approaches, right, to automate things and to provide personalization in education. Psychology provides the theoretical background of how learning happens, right? The fundamental learning processes, before we can model using the data mining machine learning algorithms. And education provides the pedagogical perspective, right? So how do we actually deliver AI, the interfacing of the AI with the education, both for teachers and the students? So it's a very interdisciplinary area. And recently, there's accumulation of big data in education area because we're now living in a world of big data, right? So compared with the traditional AIED fields, nowadays the artificial intelligence in education, right, relies a lot on big data and machine learning compared with previously expert systems. So that's why the digitalization of education help us, right, to leverage the big data to provide more intelligence and more robust intelligence in the AIED field. This big amount of data enables our researchers to explore statistical machine learning and deep learning models to support teaching and learning automatically. We have seen great works of learning analytics using traces data to automatically, let's say, predict students' engagement, dropout status, or learning outcomes. These works show that it's possible to support student learning at a large scale, right? So given the Blackboard, Canvas, edX, Google, right, YouTube use, or even your social media use, they are constantly collecting of this kind of data. If we look at the general applications of artificial intelligence in education, based on the figure inspired by Baker's work in 2019, we think in general there are 3 generic applications: learner-oriented AIED, right? For example, adaptive learning systems, also our peer recommender systems, right? It's more focused on supporting students-oriented education. And then there are teacher-oriented AIED, right? For example, plagiarism detection, right? Or providing automatic feedback or automatic grading. And then there are also institutional system-oriented AIED, right? For example, enrollment prediction, right? And then they can use various approaches, and for example, deep learning, machine learning, and statistics. So in terms of my research, specifically in the AIED, I often focus on EU structural context. What it means is this research it's not pure, let's say, mathematics or physics field, right? Because think about the physics or mathematics. Oftentimes they are like almost predefined steps to solve a problem, right? Or like to correctly answer a problem. But for example, in engineering design, right, in online learning is a pretty complex space, right? It's a very social environment, social complex issues. So you are not like, okay, I know exactly how to conduct, peer recommender. There's no like, direct solution for these kind of things, right? Then, focusing on EU structure context, and then I often use like teaching and learning theory to frame my data mining approaches or machine learning approaches or artificial intelligence models before, right, just mine big data and then come up with patterns or intelligence without much interpretability, right, or like actionable intelligence. So that's why we need like teaching and learning theory. Again, I also focus on tied to this talk is like the fact approach, which represents fairness, accountable, and a transparent approach. Because nowadays AI, right? There are a lot of like concerns, especially like in the past 3 or 5 years, about like whether it's equitable, right? Whether it's how can we hold AI accountable in educational context? Can we make it transparent so that we can improve AI's trustworthy, not only in education but in the whole society, right? So to recap, why we use teaching and learning theory, we can ensure the pedagogical meaningful interaction, right, between the interface of AI with their stakeholders. For them, in our context, right, often students and teachers, sometimes maybe administrators, right? Why we use a fact approach? We want to make sure, right, the AI is reliable and explainable interaction so that we can improve their trustworthy of the AI for their stakeholders. So one major issue, of the current AI ED research is, little is known whether AI applications in education is fair, right? For example, I want to emphasize this a little bit. So I want like you guys, help listen along, right, and think about this a little bit. So for example, a student course reader prediction model, right, is twice as likely to incorrectly predict African American students with a high risk of failure than their white classmates, right? So think about this. Grade prediction, right, or let's say automatic grading system, whatever like AI application is, right? Think about a course grade prediction or like automatic assignment grader, right? But the error rate for African American students may be much higher than their counterparts or other students, right? So this unfair prediction or like this unfair assessment, right, can result in over intervention, right, or other undesirable properties towards underserved students or underrepresented students, compared with their counterparts. Right? So this is quite a serious issue. Right? The model you build, right, has a much higher rate for certain race or gender or certain characteristics, right, compared with others. Then AI can literally like increase the inequity in education, right? Of course, right, this is a very like let's say a killer example in education, but again, fairness is not only limited to race or gender, right? Even though like a lot of like AI ED or like fair AI or fact AI research focus on race and gender, but it's actually much more. For example, maybe other, let's say, students with disabilities, right? Or students with living in rural area, right? Or students with limited prior knowledge, right? So AI bias can towards many characteristics beyond race and gender, but race and gender is much more, let's say, persuasive nowadays, right? Or like as an example, I think it's much more persuasive or like much more representative compared with others. So it's easy to show like, right, AI can lead to bias, right? Can lead to algorithmic bias. So this is the current background for for our research. So what can we do, right? So how can we like provide or improve fairness or reduce bias in AI applications in education. So this is the sort of like, general background of, fair AI in my current research. Then let's talk about specifically fair AI in education, some like a literary background, like, for example, I give you a quick example about a course grade prediction, or like, automatic grader, right? It can generate bias in education, but, fair AI is a very serious issue. If you look at like these examples, for example, Amazon's hiring algorithms, right? They are just biased against women when they try to, they find like, participants with specific demographics were more likely to be employed or like compared with others, right? And also there's another study like by, predictive policy, right? They provide much more from the AI models. They provide like a much more like a place much more police workforce over certain areas, or like with certain communities compared with others, right? So it's not only education; it's a pretty serious issue like across the whole society sphere. And there's a whole like community called ACM, right? It's a leading like let's say computer science association, and there's a specific let's say sub or SIG called like FACT, right? Fairness, accountability, and transparency. There's a whole like community dedicated to this, and it's very interdisciplinary field, rather than only focusing on machine learning or data mining, right? They are like philosophers in it. They are like policy makers in it. So it's a very interdisciplinary area. So does for the fair artificial intelligence education, or like fair AI education field, right? And so where the bias comes from in AI, right? So algorithm itself may not be like biased, right? But the data fed to algorithms and the interpretation of the AI results often can be biased, right? Think about that. When you try to classify let's say a hiring algorithm, right? Apparently, when you try to hire like tech people, they are much more males are much more represented compared with females, right? So the data fed to the algorithm to train the algorithms or to train the AI models are like underrepresented or like unbalanced already. So that's why the undesirable behaviors algorithm are reflected like by the data already, right? So and this is like where the bias comes from, or the unfairness comes from. And also like as I said, right, the AI fairness is a very interdisciplinary and complicated issue, right? How do you define fairness, right? So think about that. Do you think like is individual fairness or group of fairness, right? It can be a very philosophical question, right? So does the whole, let's say every race gets the same treatment, or every individual gets the same shot, right? So do we like provide the same, do we define fairness based on a certain demographic characteristics, or do we define fairness by individual, right? So of course in our paper we mainly like approach fairness from like algorithmic perspective, but as I said, right, there are philosophers actually like working on these kind of issues. So how do we actually define fairness, right? But algorithm, let's say from algorithm perspective, or from like application perspective, right, there are different notions: independence, sufficiency, and separation. Essentially, you can think of them as like different algorithmic approaches. So mathematical ways or statistical ways to define fairness. But again, remember there's a limitation to this kind of like definitions, right? So there's no, let's say, very agreed definition for fairness yet, but we have to work somewhere, right? Equalized odds equalized odds is nowadays from algorithm perspective is let's say a preferred metric to evaluate AI fairness for now. And then let's talk about approaches. Again, right, fair AI is a very complex issue, and in our paper, we mainly explore like an algorithmic approach or like a machine learning approaches, right? But there are more, right? Think about that. AI bias, right, from data, but the interpretation of the modeling results or like the machine learning results can generate a bias, right? Or like the implementation of the AI itself may generate a bias. I think there's like, a paper, a review paper on like AI bias in education already, right? So you can see not only algorithm or data can generate bias, the whole like, let's say design development, right? And the deployment, the evaluation part of it can all potentially generate a bias, right? So, but for this paper, right, you cannot solve everything with one paper. But I just want to talk about like, the general background beyond this paper, right? What we done is really like, let's say push a little bit towards a very specific application, but there are general like much larger issues and background beyond the paper I presented. But let's go back to algorithmic approach, right? There are like, for example, from algorithm or from machine learning perspective, there are like 3 approaches, right? Pre-processing, algorithm modification, and post-processing. Pre-processing is, as I said, right, data sometimes are imbalanced already, right? So it can, when it fits into the algorithm, it can generate a bias. So we can use like, balance, split, or transformation, right, to transform the data, and we call it like pre-processing approach. And then there are algorithmic modification, right? Adding some additional constraints into the algorithm, right, to reduce its bias. And they are like a post-processing, right? After AI makes the results, we can do some like, threshold prediction results to reduce the potential bias. So again, this is mainly from algorithm perspective, but there are more, right? For example, when you deploy the technology, when teachers see the results or when students see the results, it still may generate a bias, right? So, but this is the main background for our paper is, we use like, a certain, evaluation metrics for fairness, right? To define whether it achieves fair results or not. And we use like, we modify some algorithms to improve its potential fairness. So there are limitations, but this is mainly from algorithm perspective. And then, we talk specifically for our paper, right? Overall, in this study, we have proposed like, a fair network embedding model that serves as the engine towards like, constructing a fair peer recommender. We call this model, a fair NE, or like fair network embedding, right? Which is in general, it's like a fair network, but I hope you can see the, creativity in the naming, all right? So what is peer recommender, and how can, how can it be beneficial, and what directions can we take to build one? So I'll give you like, explanation later. So we operationalize a peer recommender in education as a system to provide students personalized social outreaches to help expand their social networks and potentially assist with their learning. So how can it assist with learning? From the perspective of help seeking in self-regulated learning, peer recommenders assist with identifying help providers, which is an important stage in help seeking, right? Meanwhile, peer recommenders can greatly improve the chances that students will receive peer feedback and suggestions on their statements or questions by providing intelligence to suggest the peers who are likely to connect. The potentially enhanced bond among students might improve students' retention and engagement with the open learning network, open online learning community, right? And also like the selection mechanism of peer recommender tends to prioritize like peers to share similar interests in this kind of topic, string the ties between students that lead to sustainable and reciprocal discourses. So essentially, you know, if you look at the highlights, you know, the 3 lines, right? So peer recommender can, to recap, is support effective and efficient help seeking, right? In open online community with over 100,000 students, right? So how can we support effective and efficient help seeking rather than ask a student to just wait and you know wait for some random answer? And it can engage students with active discussions and potentially contribute to a sustainable, you know, and reciprocal collaborative learning. So here is sort of like you know background of like, you know, peer recommender in general, right? So AI-based peer recommender. There are other ways for peer recommender, but we are focusing on like AI-based peer recommender, right? So AI-based peer recommender can be constructed essentially from 2 directions, right? A link prediction approach is to suggest peers who are likely to establish connection with the target through graph theory. So think about online learning network, right? Is as a graph, right? So we have an existing graph, and then we are going to make predictions on, okay, which are the people are likely to connect next, right? So we can make this prediction and then recommend the peers, so then they can likely to get connected, and then help each other and help us answer questions, right? So this is one direction. Another is like, you know, a student modeling approach to recommend peers with similar behavioral backgrounds. Oftentimes, you know, they do like, you know, cluster, or like, you know, essentially they put the students with similarities into the same group so that they predict, you know, they are more likely to connect, right? But it's different from link prediction. So the former, right, the link prediction provides a list of like candidates for connections, but the later can score the candidates from multiple dimensions to allow further granular matching. So essentially they put like a student, let's say, with the similarities, they put it like more likely to connect. So it's worth knowing that, you know, we can definitely create a hybrid system using both approaches. However, I don't consider that's like a major third direction, right? As the weighted decision based on the two directions here. So I consider like overall there are 2 directions, right? So from the algorithm perspective, the core component of a peer recommender is the prediction of students' possible connection in a network, namely link prediction, right? As I explained. As a first step towards building a fair peer recommender, you know, we chose to address the fairness issues in the context of link prediction first. Recent works on like, you know, link prediction suggest that, you know, using network embedding can be a huge advantage on both like, you know, computational efficiency and prediction accuracy over traditional, you know, social network analysis, right? So put like, you know, detect students sub community and for that, right? But compared with link prediction, is much less efficient. So in our study, you know, we choose to improve a network embedding to proactively, you know, mitigate algorithmic bias. So we use link prediction, right, for the peer recommender. And how do we, you know, reduce this bias in the potential link prediction for peer recommender? So this is the core part of our paper. So before, like, you know, I go deep into the link our modeling process, let's take a look at our study context and data, right? So Algebra Nation is a huge online learning platform with over 1 million students using it, and is owned by UF College of Education and another private company. So we sampled like, you know, 10,000 algebra learners from the database, along with all the posts generated by them from 2015 to 2020. After removing students without the demographic information and their posts, the final data set consists of like over like, you know, 18,000 180,000 discussion post reply pairs by over 10,000 students. So from the demographic information, we can see, whether there's a balanced distribution in terms of like a gender, race, and right. So we can use the gender and race as a potential indicator of whether the model is biased or not. But again, right, the fairness is not only based on race and gender, but this is we start from these two characters. So what we did like for the in this study is we compared the proposed fair NE, right, fair network embedding with two other network models. They are node-to-vec and fair work. So embedding is, what is embedding, right? Network embedding. So network embedding is just a fancy term to suggest everything is vectorized, right? So for every node and edge in a network, instead of using a single point value to represent them, we use vectors to represent them instead. We can use the embedding for downstream tasks such as prediction. Node-to-vec, right? So that's like very popular, very popular used in like NLP or like text mining natural language processing, right? So a word-to-vec, not node-to-vec. But so how do we get embeddings, right? The whole idea of network embedding is actually just like a word-to-vec. If you think about it, the nodes in a network graph can be treated as words. So if we select like several connected nodes, right? Several connected nodes, then we have a sentence, right? So this can sort of like transform into a sentence. Then we can use the exact same mechanism like a word-to-vec to calculate the embedding data. That's how like a node-to-vec, right? Node-to-vec compares word-to-vec, right? That's how we get its name. Is I don't think we need to go to too details of this, but fair NE essentially bears the same idea with node-to-vec, but it is main different in two ways for its fairness, right? First is Bayesian, means there's a prior involved, and the goal is to use the data to find the posterior. And unlike a fair walk, right? A fair walk, right? We can only take one predicted attribute. Fair network, can have multiple predicted attributes like gender, race, nationality, or like whether it's rural or not. So it's worth knowing that these predicted attributes do not need to be the common demographic variables, as I said, right? So, but it can be category variables such as students' learning profiles. So essentially, we propose to recap, right? To summarize, what we did is, we follow like a word-to-vec, right? There's node-to-vec, and then we like modify it a bit to add like a Bayesian in it, so that we can add some additional constraints to reduce its bias. And then we compare our fair NE with other models to see whether we can propose like a fair a less biased a fair peer recommender. Essentially it's based on link prediction, right? So we see whether fair NE can perform better. And again, right, from the evaluation metrics, we use like a different metrics to see whether we can get like a better score compared with like we are going to compare these three models, right? So we see how do we evaluate whether it's fair or not, right? So we use this like a representational bias, balanced score, equalized odds, and upper ROCA, right, to evaluate to evaluate fairness. And we use the area on the curve, AUC and accuracy, to evaluate this network embedding's prediction accuracy, right? So overall, you can think about this like we have two key index or statistics to evaluate. One kind is whether it's reduced the bias or not, right? Second is how good it performs. We don't want a model like okay, it's super fair, but the performance, the link prediction, the accuracy, or like the AUC is very low, right? then okay, it's super fair, but the link prediction or the peer recommender doesn't work, right? Because they are just not likely to connect, right? So we need to kind of find a trade-off for its accuracy, right? How good the link prediction can be, and then whether it's fair or not. We cannot only care one way or another, right? For example, it may be super accurate, but it's not very fair, right? So can we build a model that's both fair and accurate? So this is the whole goal of this. And here, here is how we set up the experiments, right? We set up experiment to train and evaluate network and link prediction model. We split the post and reply pairs, right? Namely network edges into training and test edges. And we then generate an equal number of negative edges for testing and merge them with the testing positive edges. And we use the training edges to allow the fair NE node vec, right? Node vec and the fair walk to learn latent vectors of network embeddings. And we then examine the representative bias of latent vectors, right? Representative bias using logistic regression classifier to evaluate the balance score conjugate key means, right? With the latent vectors and calculate cluster balance score. And next, we built the link prediction model with log distribution by using latent vectors from the 3 network embeddings to predict the probability of other students connecting with the targeted students. We then use the AUC accuracy to determine the link prediction recommenders predictive accuracy. And finally, we used EU and APROCA, right, to determine the prediction fairness. So this is how we set up the experiments, and then we look at whether it is before we see the results of these 3 models, right? We use network modularity to detect the community of students to examine if students have formed the community dominated by a specific race or gender, right? For example, if there are sub-communities dominated by a specific race or gender, then they are likely to recommend that. Then they are the recommender can potentially lead to bias, right? Because you are only connected with certain race or certain gender, right? So students within each community were densely connected, while there were relatively loose connected with outside the community. So it's very interesting to note that in the left figure, right? And there were communities whose members were dominantly male. And a similar pattern on race, right figure, right? We are overrepresented students heavily interact with other overrepresented students, right? You can see right? They are dominated by one certain color, right? It means they are overly connected with a certain race and gender. So the point here is, if they are overly represented, then the model can potentially generate bias, at least from data-wise, right? If we didn't do anything, the peer recommender can lead to potential bias because they are dominated by certain, demographics. I think we can skip this a little bit. Essentially, it means the same, right? So again, they are over connected by look at the highlighted ones, right? So they are over connected by their certain certain gender. And finally, we build a fair NE and compare with for both race and gender, right? Compare with node vec and fair walk. We want to see whether we can achieve better fairness or reduce more bias compared with others, right? So represented the box plot, right, show that fair network can achieve the fairness represented among the 3 models, right? You can see this compared with all other, right? It is much less bias, achieve a much fair results compared with others, and the results and also using the this is essentially another one, right? We use a okay, give me a second. So for the balance score, right? So in terms of like gender and race, we can also see fair NE performs much better. And there's another like there's another like evaluation metric, right? This figure demonstrates that distribution of yielding prediction model using different prediction scales within a threshold of 0.4 and above, right? We can see like fair network can achieve lower or comparable yield than the fair work. So essentially, we can like conclude that the proposed model, right, are much performs in general much better in terms of like fairness compared with the baseline models, like fair work and fair network embedding. Then we can see like the accuracy, right? Essentially the performance. Okay, fair network can achieve better in terms of like its fairness, but how can we does it generate a pretty accurate and reliable results, right? So all three models we can see like have very high values prediction accuracy, so that network embedding would help predict students' probability of connection accuracy. Although fair network embedding, right, fair NE, the model we proposed, right, didn't achieve the best performance compared with, let's say, fair node-to-back, right? Node-to-back apparently achieves slightly better, right? 98-21, 98-66. But but fair network you achieve the best like fair results. So let's say in general, fair network embedding can achieve a pretty reliable results in terms of fair link prediction, but it can achieve much better in terms of fairness. So I think it's pretty reliable model compared with others. And here, I like, the technology design integration, right? So we have built a fair NE model. So how do we actually integrate it into the mass nation platform, right? So what we thought about here is when students type a question, right, and then they can type an @ sign, then we'll recommend the potential peers, right? They are likely to answer their question and get connected with the student. So this is like how we actually integrate this into the education platform, right? So we built like a much fairer model, and we reduced like it achieved a very comparable prediction performance in terms of like accuracy and the AUC, right, area under the curve, but achieve much better fair results. So we need to like integrate the model into the education platform, and that's how we like actually do it, right? Put an @ sign, and then we have a list of people to recommend for the students. So this is about the peer recommender. I think I have a few more minutes, and I want to talk a little bit about like my other study in terms of like still let's say a very EU structured context, right? So we move a little bit like towards like a fair peer recommender, but think about this AI physical labs, right? So this study does not specifically address like algorithm bias in AI modeling. However, the goal of the developed learning tool is to use AI to democratize science learning in K-12 content, which can be considered falling into the broader spectrum of fair and equitable AI in education, right? So the theoretical framework, right? We always start with like a teaching and learning series, right? The theoretical framework guide us is series continuous fitting. What this means like is, students learning starts with physical insatiations, right, with their materials, and then, right, gradually move to a more abstract stage, right? So if you think about that, we can like when students work with the physical materials in the lab, right, we can use like a computer vision to monitor students' interaction with the physical materials, and then use like AI using like the VR, right, to overlay the abstract concepts in the over the the physical materials. So we can get both the physical interaction and the abstract concepts. Here you can see a little bit, right? There's a pendulum pendulum experiments, right? When students interact with the pendulum, right, we can use computer vision to track the movement of this pendulum and place it over overlay this, right? So that students can have the physical interaction and also have the benefits of this abstract concepts. Here is the Smart Head Lab, right? Students learning about thermodynamics. Students not only get the physical interaction of this, but also get the abstract concepts, of how the thermodynamics works. And I think it's pretty intense. Let's see whether this works or not. What happened? I think there's a video. Huh. Okay, let me see. Okay, give me a sec. What happened? Okay, I'm not able to show the actual video of this, but I guess that's fine.
Yeah, sometimes when the share, when you click the share screen, it'll ask you. I'm sure you know that. Yeah.
Yeah. Oh, you can see my notes again, right?
Yes, that's right.
Very weird. Why I cannot find my screen too?
Frustrating.
How about now? How about now?
Yep, that's right. That's good.
Okay. So anyway, this is essentially how we actually develop the technology. But I'll share a YouTube later. But you can see, right, in these experiments, students can work with physical materials, work with the inactive state of graphics, and finally we can overlay the abstract concepts over it, right? Then we conduct 2 rounds of experiments. First with 111 ninth grader diverse students, right? Second round is with 130 ninth grade diverse students, and the students engaged during the experimentation, right? So we measure their engagement, measure their scientific practice through the lab report and their concept understanding. And here is the whole experimental process, right? So students will work on prediction first, and then they work with the intervention. And finally, they will explain in the lab report. So, and then we code their lab report and get their log data. And here's what we have. We can see, right, students are very engaged during during the experiments. And students can, in their observation, right, students can use in the lab report, students can use very concrete, let's say images of evidence to support their claim. And also we can see the conceptual change examples, right? We do the prediction and explain sort of like pre-post test, and the students can also significantly improve. And we can see the conceptual change, right? For the specific concept. The wood ruler is colder than the metal ruler, right? Meaning the wood ruler will continue to hotter than the metal ruler. Yes, but that's before, right? But after it, yes, it depends on if it's a conductor. If it is, then it will be diffuse faster than the insular because it's either lead heated. So you can see the actual conceptual change in students' learning. So we, if we recap, what we have is there are 3 strands of AI to support the science learning. Right? So we rely on serious concurrent feeding and using computer vision and image processing to augment the students' interaction with the physical materials and to enhance student learning in the end. And I will talk a few minutes about where do we go from there, right? So essentially, as I said, right, if we go back to like the AI and the affect AI or fair AI in generic word is we only like examine like algorithmic approaches, right? The AI, even the definition of fairness is still like very limited. So we want to like examine like other algorithmic approaches for sure, right? We only do like the link prediction. We also have another paper on like their prediction, like right there, for example, their performance prediction model. But there are a lot of other AI applications in education. So how can we examine or improve its fairness, right? So we definitely want to do that. And also like we want to put like fair AI into the classroom for testing, right? Because the bias is not only originated from algorithm, right? From the implementation side, from like teacher's perspective. So what is fair, right? As I said, right? I think we recently conducted a paper on like perceived fairness, right? You think from algorithmic perspective, whether it's for individual or whether it's for a certain group, right? It can achieve fairness, but whether from algorithm perspective is fair, but whether from students' perception perspective, whether it's fair. We want to understand like what kind of factors can influence students' perceived fairness. For example, okay, if the AI modeling results or AI prediction results is preferable to me, then I consider it's fair, right? Or like when the model can explain, right, it's transparent, do I consider it's fair, right? So there are a lot of like factors to consider beyond just like let's say working with algorithms and working with machine learning models, right? So we do want to put fair AI into classroom and let's say study like the ecological system around its fairness, right? So I think we need like much more efforts and studies in this direction. And the last, we plan to, and we are actually building like sub infrastructures for educational researchers and beyond. As you can see, right, some of the concepts are pretty technical. And for a lot of like educational researchers, this may be like, let's say, not that accessible, right, to engage in fair AI research and development. So can we build some like tools, right, by leveraging the big data, leveraging the supercomputing, right, and release the for like other AI ED researchers and developers to use it. So this is like our, let's say, immediate plans for our next steps. And here is like we already work on some like fair and explainable AI sample structure. This figure like show like what's in our mind, like right, we have like from the bottom part we have pre-processing algorithm, post-processing, and XAI, right? So then we want to package it into Python and provide API services for user interface and recommender plugin, which are pretty popular one in education. This is the interface we have built, like for some like testing and evaluation. In the long term, right? If you think about like my physical labs or like the online learning, right? So online learning is like a lot of times like focused mostly online, purely online. But it's very like with the development like let's say the metaverse, right? Or like 5G, like for the quick internet access, right? So like physical virtual is very blended or blurred right now, right? So can we like, how can we build like develop and research AI in this kind of like spaces, right? So online learning not only like virtual or not only like let's say virtual space or like purely like browser, right? Or like a 3D virtual environment, how it may interact with the physical objects outside of the online world, right? So can we build design, develop, and research and investigate what kind of that environment looks like, right? So move it beyond like purely like online or virtual or like on web-based applications. And also, if you think about the AI, right? There, at least in education, right? We maybe in general, it's very like, let's say human in the loop, right? Because in education, the key purpose of AI analytics or education data mining, they are for like students or like, stakeholders, right? So there are people in it. And it's not only like, pure algorithm, run it and then it's done. It's not. So how can we build like, human machine partnership, right? To like, improve the collaboration between the AI and the teachers, or promote like the partnership between students and the AI, right? So I think there are a lot of like, synthesis research we have to do in this area. And of course, like, by developing advanced cyber infrastructure will accelerate like, data intensive research, right? But as you can see, for most of like normal, at least a lot of like AI analytics, data mining research is pretty data intensive, right? So how can we leverage the big data super computing to like promote the research discovery in general education, right? Not only like biofield technical people. How can we engage like broader discussion for the AI ED research and development? So here are some references, and I guess that's thank you. If you have any questions, right, I'm happy to talk about it. And this is probably like, let's say, a little bit more intensive compared with regular online learning research. But I think this is a very important area, and I'm happy to engage like further discussion and questions for any of these topics. Thank you.
Thank you so much, Wendy. Unfortunately, we've just about run out of time, but your contact details are in the paper itself, aren't they? And
yes.
I'm sure
Also
people, would be really keen to follow up with you if there's something in particular that they'd like to talk to you about. For me, out there, that's great, thank you. For me, you have highlighted some of those really hard dilemmas that educators often wrestle with. What are things like fairness? What do those things actually mean? Can we be, is there such a thing as something that might be neutral, that would be, the very idea of having AI in a system that actually learns, is it ever going to be anything beyond biased? It's always going to have some sort of bias. And do we just accept that, but sort of make that explicit and claim the bias that's going to naturally be inbuilt? And how do we wrestle with that as educators? It's really hard, but I love the way your study has prompted those thoughts in my head, and I'm not going to giving anybody a chance to say anything beyond that, unfortunately, just because of the time limitations. But thank you so much for that. To everybody, the recording of the session will be uploaded in due course, probably over the next week at that site. It's the ODLAA YouTube channel. And if you keep an eye on the ODLAA website for the upcoming webinars, do that, and I hope to see you at those. The final thing is that FLANS, ODLAA and ICDE, which is the International Council on Distance Education, are hosting a series of 4 webinars to be run in the second week of November this year. The week we've called APOD Week, the Asia Pacific Online Distance Education Week. And the topic is going to be global advocacy for accessible quality education for all through open, flexible and distance learning. So we're almost ready to do the advertising for that. So keep an eye out for those webinars as well. It'd be great to have you along. So just want to say another big thank you to Wanli and for Chenglu for being here as well, and for that fantastic presentation, and to everybody for joining and being so attentive to the whole thing. There are some comments coming through and thanks coming through. I won't close off until till you get a chance to have a look at that.
Yeah.
So,
thank you so much, all, and feel free to contact me if you have any questions. And I guess you are good morning and good night.
yes. Stay safe in that wild
Stay safe.
storm.
Thank you all. Yeah, thank you all for
Bye,
joining.
everybody.
Bye.